Welcome everyone. This is part one of our vibe coding course. Essentially, we're going to talk about the vibe coders vocabulary, and it's all going to be particularly about what are the terms that are actually used in today's vibe coding world, right? So think of this as your builder's toolkit, especially around code and version control. These are not just fancy tech words, these are the words that let you speak to AI agents, read error messages without panic, and collaborate with other builders like a pro. Now, here is the truth: vibe coding lets anyone build, but coding well means being understood, and to be understood, you need the right words. So, over the next 15-20 minutes, we are going to cover 17 essential terms one at a time in plain English with real examples. No jargon for the sake of jargon, just the vocabulary every AI era builder actually needs. The course is brought to you by AI-Praxis, and by the end of the session, you won't just recognize these terms, you will use them. So let's get started. All right. Now, before we dive into the terms, let me tell you why this actually matters. So, vibe coding is amazing. You can literally tell an AI, build me a website, and it does. But here's the catch: building is only half the battle, the other half is communicating with AI agents, particularly with error messages, with other humans, and with tools. Now, imagine you're building a house with a team. You can't just point and say, put that thing over there. You need to know the words foundation, beam, wiring, blueprint, same thing here. So without this vocabulary, you're stuck in a loop of vague prompts, confusing error messages, and why isn't working moments. With this vocabulary, you brief AI agents clearly. You read an error and actually know what went wrong. You collaborate with other builders without sounding lost. So, this isn't just a vocabulary lesson, this is your shared language, the bridge between I have an idea and I build something that works. So, we're going to go through this one term at a time. In fact, as I mentioned, 17 terms, right, in 20 minutes around. So let's do it. So, our first term, this is the bedrock of everything else: repository, or the repo for short. Think of a repo as the complete project folder that holds everything: every file, every line of code, every image, every document. But here is the magic: it also holds the entire history of every change ever made to them. Every edit, every addition, every deletion, it's all there. Let's have a real world analogy. Imagine you're writing a novel. A repo isn't just the current draft, it's the entire box of drafts: draft one, draft two, the version where you killed off that character, the version where you brought them back, all of it forever. So when someone says push your changes to the repo, they mean send your latest updates to that shared project folder, or so everyone and the history can see it. Simple, right? So repo is equal to your project's home. Everything lives there. Great. So you have got your repo, the folder with everything. Now within that repo, there's something more specific that's called the code base. The code base is all the source that actually makes your application work. Every file, every function, every single line that tells the computer what to do. It is the brain of your project. Think of it, in this manner, right? Um, your repo is the entire house, furniture, paint, photos on the wall. The code base is just the wiring and plumbing, the stuff that makes everything function. So when someone says the code base is well organized, they're saying the code is written cleanly, structured logically, and easy to navigate. Like a tidy workshop where every tool has its place. Messy code base, you lost in a junkyard. Clean code base, uh, you know exactly where everything is. This is what you will spend most of the time reading, editing, and talking to AI about. Know this word well, code base. Okay, now that we know where the code actually lives, let's talk about where you actually write it. And that's where a new term comes, IDE, that is Integrated Development Environment. Okay, but honestly, just call it your code editor. Very simple word. You don't need to remember IDE. So this is the software where you open files, write code, fix bugs, and basically do all of your building. Think of this like a writer uses Microsoft Word or Google Docs, a photographer uses Photoshop, a vibe coder uses an IDE, right? So that's where, okay? So there are some popular ones. One most popular is the VS Code. Free, powerful, everyone's favorite. Okay? This is where you can actually write Python programs or you can write anything, in fact. This is built for, so then there is another one. I mean, there are many. So let me just take one example. For example, Cursor. This is built for AI collaboration. Okay? There are others as well. So you have anti-gravity, you have Codex, you have Emergent. There's so many. Right. But these two that I talked about, that is VS Code or Cursor, could be starting line. Right. When someone says open it in your editor, they actually mean, or they literally mean, launch the app, click the file, and start looking at the code. That's it. There's no mystery. So your IDE is your workshop bench. Everything you build there. Get comfortable with it. You'll be spending a lot of time inside that. Now, let's talk about the thing that intimidates every beginner. That is the terminal and called the CLI, that is the command line interface. Now, here is the truth. Okay. It's just a text based window where you type commands directly to your computer. There are no buttons, there are no menus, right? So you remember when you open your terminal of your Windows, you find that C colon slash and then the greater than sign. And that's where the cursor that actually blinks, right? Okay. Uh, so just what you do, you simply, type words and the computer actually does what you say. Think of it like texting your computer. Instead of clicking a new folder, you type mkdir, give us put us press the space bar and then write new folder. What it actually does, it actually creates a new folder. So mkdir is make directory, right? So same result, but the language is different. Why bother about it? But because some tasks are faster in the terminal, installing packages, running your project, checking Git status, one line instead of 10 clicks. Don't worry about these terms that I've used. We are going to actually cover all these. So when someone says, run this in your terminal, they mean open that black window, type the command, hit enter, and watch it happen. It looks scary, but it's not. It's just a conversation with your computer. And after a few tries, you will actually prefer it for certain things. Okay, So this one's easy because you already know it. You just need the right word. Okay. A directory is just a folder. That's it. Same thing. That's it. So folder structure or directory structure is simply how your project's files and folders are organized and nested inside each other. Think of your laptop. You've got a bunch of documents folder inside that, maybe a work folder, inside that maybe a projects folder. That's the folder structure. So a folder inside a folder inside a folder, something. So in coding, this matters a lot. A good folder structure means anyone can open your project and instantly know where things live. The code is here, the images are there, the settings are over there. Okay, so when someone says check the folder structure, they mean look at how the files are arranged. Is it clean? Is it logical? Or is everything dumped in one giant mess? Messy folder structure means lost time. Clean folder structure means you find what you need in seconds. All right. File extensions. You see these every single day, probably without thinking about them. The file extension is just the letters after the dot in a file name. Okay. For example, .js, .py, .html, .css, .md, .docx, .xlx, okay, or .pdf. I hope now you are able to understand. Okay. And here's why they matter. They tell your computer exactly what type of file it is and how to handle it. So think of it like food labels. You see, .mp3, for example, right? You know that it's music, right? JPG, for example, or PNG, that's an image. Okay, so in coding, we have something called .py, which means it's a Python code. It's a Python file, right? Python is a programming language. Likewise, we have .html. This means it's a web page. .js, which means it's a JavaScript. Okay. Same project, different jobs. App.py is doing, backend logic. Index.html is showing the front end. Okay. Style.css is making it look beautiful or pretty. The extension tells the computer and you what's doing what, who is doing what, in fact. Okay. So when someone says check the .env file or open the .md file, the extension is your clue. Okay. It's the file identity card. Know it, use it, love it. Now we move into documentation. And our first doc term is .md file, which stands for Markdown. Now, let me tell you why this exists. Back in the day, right, if you wanted front end or let's say, formatted text on the web, you had to write HTML, which, stands for hypertext markup language. For example, you want a heading, and there's a structure to write the heading. You type, you know within greater than less than greater than symbol like h1, and then the heading that you actually want, and then less than, forward slash, and then h1, and then you close it. If you want to make it bold, you in fact used to write strong between the two, less than, greater than, then bold text, and then once again, this less than slash strong. So you would have come across all this, right? If you wanted something else like a list, for example, the structure was quite different. So it worked, but it was clunky because every time you have to use, those two, uh, less than, greater than, right? You spend more time typing all those. Those are called actually tags, okay? Than actually the actual content. So you spent less time in writing the content, okay? Coders thought there has to be a better way, right? So they invented something called Markdown, okay? A way to format text using plain characters that humans actually want to type, because we understand English, we know English, all you know need to know English, right? And it's very easily you can do. For example, if you create a heading, you just type hash symbol and write it. That's it. If you have to make a certain things bold, for example, so within two asterisk sign, you just put something, it will become bold. Okay. If you have to list down, right, just put a minus sign, or let's say a hyphen, one below the other, right? Or you put 1, 2, 3 kind of numbering, because this is what we have been doing. This is our writing style. So there are no angle brackets, no closing tags, right? No mess. Okay. So if you compare it to HTML versus, let's say, the Markdown, the results are the same, but this is quite intuitive. It's very easily understood. I will say 10 times faster to write. So when someone says it's in the .md file, they actually mean open the text file, which is readable as a plain text, beautiful when rendered. Most project notes, for example, readmes, okay, and instructions are .md because they're universal, clean, and coder friendly. Markdown is what happens when coders get tired of typing the tags and just want to write. Okay, now that you have learned this, right, I just used a term, a word called readme. Okay, so what is readme.md? This is something that you should always know. Okay, so the readme.md is the very first, you can say, file human or AI opens when they land on a project. Think of it as the front door of your house. Before anyone steps inside, they read this. Okay, what does it contain? So there are three things basically. One is, what is the project? What does the project do? Right? Then how to set that up and how to use it. That's it. Okay, there are no secrets, no mysteries, just a clean, friendly introduction. Now, here is the mindset behind it. Coders are lazy in the best way. They don't want to dig through, 50 files to understand your project, and that's also the best way to uh, make others, understand things. They want the summary up front. So the readme dot, MD gives them exactly that. Okay, the TLDR of your entire project. Okay, too long and didn't read. These are the phrases that you actually use. So when someone says check the README, they mean read the intro file first before asking questions. And it's not dismissive. It's actually efficient because the answer is probably already there. So every project you build with a good readme.md, every project you use, read the readme dot first. It's the golden rule. Now we are into project setup. And this term is huge. Dependencies. It's also called the packages. Okay. So here is the idea. You don't build everything yourself. Imagine you're, baking a cake. Okay. You don't grow the wheat, grind the flour, or raise the chickens for eggs. Okay. You buy those ingredients and focus on making the cake. Dependencies are the same thing. Pre-written code that other people built and shared with the world. Okay, need to send emails? There's a package for that. Need to connect to a database? There's a package for that. Need to make your website look beautiful? There's definitely a package for that. Okay, instead of writing thousands of lines yourself, you install a dependency and you use it. Okay, so standing on the shoulders of giants. So when someone says install the dependencies, they mean download all the external packages your project needs to actually run. It's like restocking your kitchen before you start cooking. Without dependencies, you're coding in a vacuum, right? With dependencies, you're part of a global community of builders sharing tools. All right. So we just talked about dependencies, which are those external packages your project needs. Now, how does your project keep track of all of them? Okay. There comes package.json. Think of package.json as your project's ID card and shopping list rolled into one. It's a single file that tells you what's this project called, what version is it, what dependencies does it need, what commands you can run. It's the source of truth for any JavaScript or Node project. Here's the magic moment. When someone clones your project, downloads it fresh, okay, they run something called npm space install. That command reads the package.json and says, okay, I need this package, this version, that version. It downloads everything automatically. There's no guesswork, there's no manual hunting. So when someone says, check the package.json, they actually mean look at the file to understand what the project needs and how to run it. It's your project's recipe card. Without it, complete chaos. With it, anyone can replicate your setup seconds. Okay, so the term is critical and it's about sensitive information, right? Um, so think in this manner. When you want to keep your secrets safe, there is a term that we use called environment variables or .env, right? So any file that has this format will have .env. We call it as .env file. Now, understand this problem. Your code sometimes needs sensitive information, as I mentioned, such as API keys, passwords, database URLs, but you cannot just paste them directly into your code. Why? Because your code gets shared. Code gets pushed to GitHub, and if your API key is sitting there in plain text, anyone can actually steal it. So coders came up with a solution. Okay, store those secrets outside your code in a hidden .env file. Your code reads from this file, okay, but the file itself never gets shared publicly. It's on your computer and your computer only. How good it is? Think of it like this. Your code is the restaurant kitchen. It's visible to everyone. The .env file is the safe in the manager's office. Only certain people have access to it. Okay. When someone says add your API key to the .env file, they mean keep that sensitive information out of your visible code. Protect it. So the golden rule is .env goes in your dot git ignore, which is actually a list of git right should never track, list of files git should never track actually. So never in fact commit any secrets ever. So you don't have to worry about what is git ignore and all. Once you understand git and github, you'll understand what these are. Okay, now we enter the most important section of this entire course. This is version control. Okay, and the king of version control I was talking about term called, so the king of version control is git. So what is git? Git is a version control system that tracks every single change made to your code over time. Okay, every edit, every addition, every deletion, it's all recorded. Who did it, when they did it, and why. So you can install Git. Git is actually a software. You can install it on your machine. Think of Git as a time machine for your code. Messed something up, go back to yesterday's version. Simple. Want to see what changed last week? It's all there. Collaborating with someone, in that case, Git merges your work together without chaos. So here is the key distinction. Git is like an engine. It's a software running on your computer doing the tracking. But GitHub, now there's another term called GitHub, which we will cover, of course. right? Now, this is just one place that hosts Git repositories online. We just started with repository, okay? So Git is the brain, GitHub is the house. When someone says commit your changes with Git, they actually mean take a snapshot of your code right now, okay, with a note about what you did. So let's say you did some changes. For example, you added a feature. So you mentioned that added a feature, dark mode, for example, okay, and that becomes your commit. So Git is not negotiable for serious builder. Learn it, use it, and love it. Of course, then we're going to learn about GitHub, right? So Git is the engine running on your computer, tracking every change. Now, where do you store and share all that tracked code? That's where GitHub comes in. So GitHub is actually a website that hosts your Git repositories online. Think of it as a Google Drive for code, but built specifically for developers with collaboration superpowers. Okay, here's what GitHub lets you do. Backup your code online. So if your laptop dies, your work actually still stays. Share your code with a simple link. Okay, it's on GitHub. This phrase basically means anyone can access it. Collaborate with other humans or even AI tools by working on the same code base together. When someone says it's on GitHub, they mean the code lives online at a shareable repository link. Uh, you can click it, view it, download it, or contribute to it. So what's again, right, the difference between Git and GitHub? You have to remember one thing, that Git is the software doing the tracking. GitHub is the platform hosting it. So you can use Git without GitHub, but for most builders, uh, they work hand in hand. Now we are getting closer to the heartbeat of Git, the thing you do constantly, okay, which is called commit. Now, what is a commit? A commit is a saved snapshot of your code at one specific moment in time. Think of it like a checkpoint in a video game. You reach a safe spot, you hit save, and now you can always come back here if things go wrong. So every commit has two parts: the snapshot, the actual state of your code at that moment. Okay. Then the second one is a message, a short note describing what changed. Something like, in double quotes, you write maybe fixed login bug. So you just actually write this and you save it, or added dark mode feature, which I mentioned. Okay. So here's why commit matter. Right. They let you undo mistakes fearlessly. That's one. If you break something, roll back to the last working commit. Uh, want to see what you changed 3 days ago? Browse the commit history. When someone says commit your changes, they mean save the version of your code right now with a note about what you did. So there's a pro tip: commit early, commit often. Okay, small, clear commits are better than one giant commit with vague message. For example, stuff. Okay, what is stuff? It could be a very big thing. So do small changes, right, and have short, messages for that, and your future self will thank you. All right, you have made your commits, your snapshots saved on your computer. Now, how do you get them to GitHub? And how do you get other people's work back to your machine? Two words: push and pull. Push sends your saved commits from your computer up to the online repository. It's upload. You're saying, hey GitHub, here's my latest work, store it, back it up, or share it. Pull brings the latest changes from the online repository down to your computer. It's download. You're saying, hey GitHub, what did everyone else do? Give me a fresh version. Think of it like a cloud document. Push is equal to you hit save and it syncs to the cloud Pull is equal to you open the doc and it grabs the latest version. So when someone says push your changes, they mean upload your work. Pull the latest means download everyone else's latest work. In simple, push is equal to upload, pull is equal to download. That's it. Two directions, one workflow. And now here's a term that will save you from disaster and keep teams sane, and that's called branch. A branch is a separate parallel copy of your code where you can, safely experiment, try new features or fix bugs without touching the main working version. Okay. Solo example, let me just give you. You're building a website. Okay. The main branch is live and stable. You create a branch called dark mode. Okay. To add a dark theme, you break things, you fix things, iterate freely. When it's perfect, you merge it back to the main branch. The live site was, never at risk. If it all goes wrong, delete the branch. Okay. Highway never knew anything happened. So what was the highway? Simple. What happened in the main branch. Okay. So if now let me give you a team example. Imagine five people are working on the same project. If everyone edits the main branch directly, it's actually a chaos. Person A will break login. Person B, let's say, is redesigning the home page. Person C is fixing a bug. So everyone crashes into each other. With branches, each person works on their own lane. For example, the team member Priya is fixing the login, Rahul is redesigning the home page, or Ananya is patching the bug. They all work in parallel, independently. When each feature is ready and tested, they merge back to main. There are no collisions, no stepping on toes. So when someone says create a new branch, they actually mean make a safe copy to experiment in, whether you're solo or a team of 50. Branches are your safety net and your traffic system. Use them always. Okay. Now you've created your branch, done your work, tested it, and now it's ready. How do you get those changes back into the main project? And that's where merge and pull request come in. So what's a pull request? Or in short, we call it as PR. This is a formal request to merge your branch's changes back into the main code base. Think of it like submitting a proposal. Hey team, I've done this work. Please review it. If it looks good, merge it in. Okay. So here's the workflow. You finish your feature in one branch. Okay. You open a PR, okay, pull request, and this notifies everyone. Others or even AI review your code. They leave comments, suggest changes. Once approved, someone hits merge and your branch becomes part of the main code base. Okay. Why the review step? That's very important because even the best builders can make mistake. Think about it. So a second pair of eyes, catches bugs, improves quality, and shares knowledge across the team. When someone says open a PR, they mean propose your changes for review before they become official. So merge is equal to combine, PR is equal to the formal process to get there. This is how professional teams ship code, clean, reviewed, and approved. And just like that, 17 terms, done. So let's take a breath and look at what you've built. From repos to pull requests, you now have the vocabulary to read, write, and talk about code with confidence. You know what a code base is. You understand Git, GitHub, commits, branches, merges. You get why readmes matter and why .env files, keep secrets safe. This isn't just theory. The next time you wipe code with a AI agent, you will say commit my changes instead of say this. You will ask it create a new branch before experimenting. You will read error messages and actually understand what they're saying. But we are not done yet because this was just part one, the foundation. Part two is coming, and it takes your project from your laptop to live internet. It, we're talking about deployment there, hosting, and most exciting is the vocabulary of working with AI agents directly, the prompts, the context, the workflows. You now speak the language of builders. So part two will make you fluent. Thank you for being here. Go build something, and I'll see you in the next session.